Hello, my name is Iván Nicolás Romero Bartolo, and in this video I will present you a critical analysis of Trickling filter applications using AI tools. But first, what is a Trickling filter? Well, to begin, a trickling filter is an attached growth biological reactor. Wastewater flows over a media bed like rocks, gravel, or plastic, where a biofilm develops. This biofilm is responsible for removing organic matter and nutrients. First, trickling filters achieve high removal of organic matter. For example, in the study by Usmain, the system removed up to 99% TSS, 98% BOD, and 94% COD. The Iván study, which uses a septic tank combined with a trickling filter, also reports a strong performance between 74 to 77 removal of COD and BOD. They are also low-cost systems, require little energy, and the biofilm is very stable under shock loads. Because of this robustness, trickling filters are ideal for rural or water-scarce regions. When I generated the podcast using Notebook LM, the summary was useful, but it did miss several important technical points from the articles. For example, it barely mentioned the issue of fecal coliforms in the Usmain study. Even though the system achieved some reduction, the fluid was still above irrigation standards. It also didn't emphasize the high nitrate concentrations reported by Usmain, which is well above reuse limits. Another problem is that the AI grouped all trickling filters systems together, ignoring key differences. For example, Iván evaluates a hybrid ST-TF system, while Usmain and Tisema analyze full-scale TF systems with very different influent loads. And finally, it didn't fully explain the technical reasons behind system failures, such as the lack of anoxic zones for denitrification, variations in CN radio, or the operational differences between plants. First, Iván uses a septic tank plus trickling filter, which provides good solids removal and improves the CN radio before the wastewater reaches the filter. In contrast, Usmain and Tisema use stand-alone trickling filters with much heavier influent loads. Second, regarding nitrogen removal, Usmain's system achieves nitrification but not denitrification, so nitrates accumulate. Iván's system septic tank creates anoxic conditions that allow partial denitrification, leading to better nitrogen control. Third, Usmain also fails to meet fecal coliform limits, which is a major barrier for irrigation reuse. So overall, the differences in system design, influent strength, nitrogen pathways, and microbial indicators explain why the articles reach different conclusions. But can we talk about the effectiveness of the AI podcast as a learning strategy? Well, using the AI podcast as an initial learning strategy was actually helpful. It gave me a quick overview and helped me organize the key concepts before reading the full papers. However, the podcast was not enough for technical analysis. It oversimplified several critical aspects, and without reading the articles myself, I would have missed important details. So, the podcast works well as a first step, but it absolutely must be complemented with deep reading and engineering judgment. It can summarize complex literature quickly, connect ideas efficiently, and help students to get started on unfamiliar topics. But there are also risks. AI may omit key details such as nitrate behavior, fecal coliform levels, or CN radios. It can also misinterpret or generalize conclusions. And the biggest risk is relying too much on AI without validating the information. Thank you very much for your attention.